Algebra 2, Unit 1, Quadratic Functions and the Complex Number System. Target 4, I can graph a quadratic function. Today our focus is on quadratics that are in vertex form. All right, so let's look at what is a quadratic. First off, all quadratics are of the form x squared. And they all take the shape of a parabola. So they all have this basic U shape. And they all have some basic parts that we need to make sure we know. We need to know what an axis of symmetry is. The axis of symmetry is the part that goes right through the middle, and on each side, it's exactly the same. That's why it's called the axis of symmetry. It's the same on each side. Now this middle point that the axis of symmetry goes through, that's called the vertex. Now what you're looking at here is called the parent function. This is the parent function for all quadratics, y equals x squared. And all quadratics have the same basic shape of the parabola, and they all have the same basic formula. A few adjustments though. Once in a while there'll be an a value, so you'll have ax squared, or there'll be a b, ax squared plus b, or plus c. That's called standard form. What we're going to look at again is vertex form. That's this next one. The vertex form is a times the quantity x minus h squared plus k. And what we got here is h and k, they mean something, right? They are transformation numbers. They're showing us how far our parent function has been translated, all right? H is a horizontal shift. H is a horizontal shift, and K is a vertical shift. Now, if we look at it, normally we start here at our vertex, and then we'll move at H and K. Right? So really what HK is showing us is that's the new location of the vertex. And one thing to keep in mind here is it's subtraction in the formula. So if it's a negative value, it's going to be a positive shift to the right. That's for H. And then for K, it's already positive, so you're going to do what you see for K. You go up or you go down. And so our vertex, in vertex form, you're going to be able to read it right out of the equation. There's H, K, that's the coordinates of the vertex. And our axis of symmetry goes through the vertex. Well, our axis of symmetry is x equals whatever our h value is. That's the vertical line that balances our parabola. And A, if A is positive, greater than 0, we're going to have a normal upright parabola. It's going to open up, and look like a cup. All right, if A is negative, A is less than 0, we're going to open down like a frown. Right? A is positive, open up like a cup. A is negative, down like a frown. All right, so let's look at an example. We got y equals negative 1/4 x plus 2 squared plus 5. All right, so let's solve this. Let's first look at the constants. We got a is negative 1/4, h is negative 2, and k is 5. So, because a is negative, parabola opens down. Going to look like a frown. Next, plot the vertex. We know h is negative 2 because it's got to be the opposite, and k is positive 5. So our vertex is at negative 2, 5. And you can see we plotted the vertex there at negative 2, 5. And our axis of symmetry goes through the vertex at x equals negative 2. It's the x value. All right. And then we're going to plug in a couple values so we can get some more points. Always easy to plug in 0. If you plug in 0, you got negative 1/4 times 2 squared. 2 squared is 4. Negative 1/4 times 4 is negative 1 plus 5. That's where the 4 comes from. So at x equals 0, y is 4. 0, 4 right there. And then you plug in 2, work that out. At x equals 2, y is 1. And because it's the axis of symmetry, we can reflect it. So this point right here takes 2 points to get, or is 2 units away from the axis of symmetry. 2 more units will cross it. Same thing on this point. 1, 2, 3, 4 to get to the axis of symmetry. 1, 2, 3, 4 past the axis of symmetry. And we get rid of the points. Once you got those points, you got your vertex, you got a couple more points. The only thing left to do, connect the dots, and you've got yourself your parabola. All right? Let's look at an example. Excuse me. Now, you can watch this worked out on YouTube. There's the link for you. You can't click on it because this is not that type of YouTube video. But we got the Tacoma Narrows Bridge in Washington. It has 2 towers that rise 307 feet above the roadway and connected by suspension cables. All right? The cable's modeled by the function shown. X and Y are in feet. What is the distance between the 2 towers? Well, a couple things. Our vertex is at 1427. So that means this point right here is the point 1427, because that's our vertex. That means we moved 1400 from the left and 27 up. Well, if we want to know the distance between the towers, and this is symmetric, if this part is 1400, how much is that part? That must be 1400 as well. So what is the distance between the 2 towers? 2,800 feet. All right? Let's look at some more problems. Graph the function, label the vertex and axis of symmetry. So we'll start, let's look at our A, H, and K. All right, A is 1, H is negative 2 because you go opposite for H, and K is negative 3. So that means since A is 1, it opens up like a cup. Our vertex will be at negative 2, negative 3. So our vertex is right here. And our axis of symmetry is x equals negative 2. So our axis of symmetry comes right through here. So now what we need to do is we just need to plot a couple more points. Okay? When x is 0, that's an easy point to plot. Y equals 0 plus 2 is 2. 2 squared minus 3. 4 minus 3 is 1. So when x is 0, y is 1. Reflect that over the line of symmetry. Let's plug in, let's do 2. If x is 2, what do we get? Well, if x is 2, 2 plus 2 is 4. 4 squared is 16. That's not going to fit on our graph. Let's try x is 1 instead. 1 plus 2 is 3. 3 squared minus 3. 3 squared is 9. 9 minus 3 is 6. So when x is 1, y is 6. That put us right there. Reflect that. Now we got enough points for a parabola. Connect the dots. There is our parabola. And it opens up because A is positive. All right, looking at another example. As we look at this one, identify our constants. Where A is negative 1, H is 1. Again, we're going opposite for H. K is 5. So that means this one opens down. And our vertex is at 1, 5. And here's our axis of symmetry at x equals 1. Now, let's plug a few points. Plug a few points, see what we got. All right? If x equals 0, we got y equals negative, okay? 0 minus 1 is negative 1. I'm going to square it anyway, so it's just going to be 1 squared. Plus 5, so 1 squared is 1. We got negative 1 plus 5 is 4. So add 0. X is 0, y is 4. Reflect it. All right, let's do another one. Let's do 4. If x is 4, well, if x is 4, we got 4 minus 1 inside parentheses. 4 minus 1 is 3 squared plus 5. 3 squared is 9, so we got negative 9 plus 5 is negative 4. So when x is 4, y is negative 4, and reflect that. So now we got our axis of symmetry, we got our points. Connect the dots. There is our parabola. All right, one last example. Pause this one, try it, see how you do. All right, so identify A, H, and K. A is 1/2, H is 3, K is negative 4. This means it opens up. It's a good check to make sure. Our vertex is at 3, negative 4, and our axis of symmetry is x equals 3. So 3, negative 4 is right there. Bring our axis of symmetry right through. All right, let's plug a few points in. We'll plug in 0. I always like to do 0. It's so easy to calculate with 0. Y equals 1/2. 3 squared minus 4. 0 minus 3 is negative 3, but since I'm squaring it anyway. So 9 halves. 9 halves. That's 4.5 minus 4 is 1/2. So, and x is 0. Y is 1/2. Okay, and then let's reflect that. Let's try when x is 2. Right? If x is 2, what do we got? If x is 2, we got y is 1/2. 2 minus 3 is negative 1. We're going to square it, so I'll just go positive. Okay, so we got half of 1 minus 4. Half of 1 is half, minus 4 is negative 3.5. So when x is 2, y is negative 3.5. Reflect it, and connect the dots, and there's our parabola. All right. So in review, make sure you know what A does. It tells whether we open up or down. Make sure you know what H and K are. Focus on using the opposite of what you see for H and the same as what you see for K.